As a plant manager at cellfab, Enrique's been tasked with boosting production to meet a recent spike in demand for electric vehicle batteries. In the past, to find performance inefficiencies, he was stuck with old reports built from siloed and incomplete datasets. But this quarter, Enrique knows exactly how his plant is performing. His team has been using digital performance management, software that provides a systematic, comprehensive, and always current view of performance by leveraging real-time production data and a closed-loop approach to continuous improvement. Enrique and his team use DPM to know how to focus, prioritize, and validate improvement efforts so they can boost battery production and meet demand. DPM captures real-time production data from automated equipment and lets frontline workers account for all their lost time on the production dashboard, which helps cellfab monitor production and standardize all losses on time. This same data fuels Enrique's bird's-eye analysis of factory KPIs, where he can filter from an enterprise view or by business units down to specific factories and lines. The factory OEE is low, indicating that cellfab's throughput isn't keeping up with demand. Enrique's goal is to understand why OEE is low and how to fix it, but first he needs to know where to focus his improvement efforts. DPM focuses Enrique on bottleneck constraints, helping him avoid slow manual analysis, quickly identify the biggest slowdowns, and prioritize high-impact performance initiatives while the data is still up to date. With bottleneck analysis, Enrique can see that the battery cell assembly work center is the biggest bottleneck. Drilling down into this work center, Enrique can see all the available time, how effective the line is with that time, and the root causes behind the plant's lost production time. First, Enrique can see his biggest categories of lost time, like changeovers, speed losses, and scrap, which are all standardized to minutes and hours lost. At 25 hours, he's losing the most production time to unplanned downtime. For more detail, Enrique can drill into unplanned downtime to see its root cause loss reasons, from emergency stops to power outages, all data captured automatically from sensors or from the operator during their shift. Here, Enrique can see the single biggest reason for his time loss, the safety stop on the robot that assembles cellfab's battery cells. If he can regain just the time lost to the safety stop, Enrique can reallocate these lost hours to effective time and increase throughput to meet battery demand. To eliminate the safety stops, cellfab's continuous improvement team designed a lighter plate for the robot's arm, so it could stay below the force threshold that triggered the safety stops. Cellfab tracks and measures the impact of their efforts using DPM's action tracker, which lets them create continuous improvement actions tied to real-time production data, ensuring they're always addressing their top losses. So a week after installing the new plate, Enrique can see that his time loss on the stacking robot dropped to 0 the day the plate was installed, and that his team recovered almost 13 hours by fixing the safety stop. With the new plate, cellfab's now not only meeting but exceeding their battery production targets, and Enrique can cut the overtime shifts they were running to try to meet demand. With digital performance management, managers like Enrique can proactively identify the production issues causing bottlenecks, analyze root causes with comprehensive, up-to-date machine metrics, and make data-driven production decisions. This standardized, closed-loop approach to problem-solving leaves no question about how the team's continuous improvement efforts impact production so they can propel cellfab to the forefront of manufacturing.